If you want to know an easy way to make 3D games with GameMaker, or if you're coming here from my previous 3D tutorial, you've clicked on the right video. As requested by Ignacio Slothboss, this is a more in-depth tutorial on 3D with GameMaker. Let's dive in. So let's just go right into the project files. First, I'm going to show you guys my sprites that I've made. So here I have my sprite for my player. Now this is just a very simple breathing animation, only 4 frames. This is just what I've created. And now here I have another 2D image, just kind of this little animated sci-fi incubator here with bubbles coming up. And now here it's gonna be hard to tell what this is, because if you play the animation, it doesn't look like how it looks in the game, and that's because we're programming our 3D obstacles differently than our 2D obstacles, which I will go into later in this video. For now, I'm just skimming through these. This is the background, and then we just simply have our camera object, which is camera sprite, which is actually invisible. So let's open up these 3 scripts. The first one, scr_depth_3D. So let me just explain exactly what this is doing. Global Z is a global variable that I've set myself. Now, global Z is actually set in this project in the player object. If you're doing a larger scale game, I might recommend setting that in the camera object, or maybe not necessarily the player object. There are some better ways to do this, but this is just simply how I've done it. This is not the best or the most efficient way, but this is how I've created this and I've found is the best way for me. So basically, the Z-axis is going to be where our camera is facing. So the camera and the Z-axis are all going to be the same thing. So if your camera rotates to the left, your Z-axis is rotating to the left. And basically, what this determines is where things that are being drawn in a 3D or a pseudo 3D way need to be drawn in order to look like they are 3D and look like they are alive in this world, rotating with the view. So this is simply this entire script right here, scr_depth3D. All that this is doing is this is telling your objects exactly in what order to draw themselves. And that has to update every time that your view or your global Z is updated. So if you'll notice here at the very bottom, your camera rotates with your global Z. But basically all that this is doing is, so typically in a 2D game, you would want to set your object's depth to -y. And what that does is that will set things to where if they are lower on the y-axis, then they will be drawn in front, where if they are higher on the if they are higher on the y-axis, which would mean that they were behind an object that's lower on the y-axis, that they are drawn behind. So this is a very common, so in many 2D games, a very, very common depths to program depth would be something like depth equals -y programmed in the step event. So this is basically taking that, and this is saying, okay, well, if you're facing how you would normally be facing in a 2D game, then your depth or your Z-axis is going to be -y. Same here. The reason that there is 2 of these for facing north is because the way that the direction works, it's 0 to 360. So you kind of have to break these up. I couldn't do if global.z is greater than equal to 315 and less than -45, because then it would be all kinds of weird, and you get glitches from that. I'm sure there's a way around that, but this is just, I've just done it twice here. So facing east, so if your global.z, or if your camera is facing to the east, then it's going to, so your camera is going to be rotated to where you're actually looking up on the x-axis. And so then, obviously, if you're facing south, it does positive y instead of negative, and then west is going to be negative x. So all that this is doing is this is just telling the objects in what order to draw themselves. And this is the best way that I've found to do it. I'm sure there are better ways and more efficient ways, but this is just what I've created. And so here is where we actually link the depth with the z-axis. And now, so basically this, since we're using numbers somewhat outside of, well, so in the player, the player controls the global.z with the left and right buttons. And so since we're using real numbers in that and not actually technically using direction, which is 0 to 360, we have to limit this so that it doesn't go to, for example, 365 or to -3. And so that just catches this, keeps it in that range. And then here we're setting that. So, done with the first script. Now, this is, like I mentioned in my last video, if you didn't see that, part of this comes from a script that I used that Heartbeast did a tutorial on, and that is over Sprite Stacking. He's not the one who invented it, but he's the one who actually showed me how to make that and how to do that. And basically that is, let's see here, that is this right here, and then everything that I've done outside of that is my own implementation. So basically, normally if you're doing sprite stacking, you would stack the sprites on the y-axis. If you're not familiar with sprite stacking, I definitely recommend checking out Heartbeast's video. I will put a link in the description, but I will do my best to explain it. Basically, you're taking different parts of the sprite and you're drawing them on top of each other with an offset so that it makes them appear 3D. So that's why this looks, you know, like this whenever it's animated. But in reality, since we have implemented the sprite stacking script into this 3D object, it's not going to be drawn as that type of animation. It's going to be drawn, so if you see those cubes, now what's happening as I'm rotating the camera, that's updating our global.z, which is working together with our view angle, so our camera angle, and then the way that objects are drawn is also playing off of all of those things together. So there's a lot of connected pieces here. And if you'll notice, so now I am drawn behind, but if I rotate, now I'm drawn in front. And that's the SCR Dart. I don't remember the exact name of the script, but our depth script. So Heartbeast does a way better in-depth tutorial on sprite stacking. I don't want to touch on that too much. I just want to kind of give you guys the basics of that. So basically, all that I'm doing here is I'm just basically setting a few parameters in place so that we know, basically, hey, instead of drawing only along the y-axis, draw it along the z-axis, the global.z axis that we've created, which we create in the player event, which I'll go over here in a second, rather than just on the y-axis like in a normal singular view angled game. Now this is also important to set the image speed. Otherwise, all of these frames that it was drawing standing still would be, so they would essentially look like they're flashing through this animation, every single one of them. And that's not what we want for sprite stacking. We always want that image speed to be 0. I'm sure there are a few different reasons you might not want that. For example, if you were doing, maybe some sort of animation on that. I don't know. That would be tricky to pull off, and there are other ways to do it. But yeah, we want that image speed to be 0. Third and final script, and this one's the easiest. Okay. I mean, this is just some really, really advanced stuff here, people. So hold on to your seats because I don't even think programmers at Harvard would be able to crack this one. So all that we're doing here, draw sprite ext, we are drawing, so whatever the frame is, so, you know, whenever our player is breathing, whatever frame, 0, 1, 2, 3, and then we're drawing, or excuse me, that would be for the image index, I apologize, sprite index. The object of the player has this sprite player. We're drawing it at our X, at our Y, which this is actually centered at the base. Now, it's important to center your 2D sprites at their base, because in the real world, if you're looking down at something, you would want, so from a kind of 3/4 top-down perspective, you want them to rotate at this point rather than in the, so say in the center, because then it would just look like it's kind of rotating in a way that's not natural to the world that it's in. So we're rotating, we're drawing at the X and Y, but then we are rotating, so rotation is going to be along the global Z from the point of origin. We're using the image X scale, image Y scale, which typically is +1, but if you want to do a squash and stretch script, you can implement that as well. We're drawing it white because that's going to keep its original color, and giving it an alpha of 1, it's going to be completely visible. There's not going to be any transparency to it. If you wanted transparency, you could do something like 0.5, or if you wanted it completely invisible for some reason, 0. So yeah, that's probably the most basic script out of all three. And now I'm actually going to show you how these are implemented into the objects. So this is just simply a collision parent for, since we're programming, or since I've programmed this entire project in the physics world using the box 2D physics, this is just simply all collidable objects get this. So the player collides with the 3D obstacle and it collides with the 2D obstacle, and then these all take on this collision event where the box 2D physics is handling all of it for us. So that's just simply a parent object. Now the player object has the bulk of the code. Like I said, there are better, more efficient ways to program this, but this is just how I wanted to program it. There's always going to be a better way. Just program it and get it done, and then you can clean it up if you wish. So it uses physics. And now here's something that's really important. When you're doing the collision shape for these objects, you want it to be at the base, because the player, you know, the head right here, let's say an enemy comes behind the player, or, you know, we don't want it to stop right here. We want it to stop right here. So let's say this 3D obstacle. We don't want to collide with our head because our head is, you know, in a 3D space, it's along the Z-axis. We only want it to collide at our base. So for all those, always make sure and do the base. Now, create event. We are setting the animation speed to 1. You can set it to, that's, you know, not entirely necessary. It just depends on your animation. That's just how fast it's going. So like I said, here we're setting that global Z. I said this earlier, I want to say it again. I would recommend, if you're doing a larger scale project, maybe doing this in the camera object, but just for this sake, starting out at the create event, your global.z, or your view angle, equals 0. And then we're just going to create our camera object, which is what the room follows, and then we just have a very simple, yeah, I might as well. Literally, this is the only code in here. Yeah, so this is just a very simple, smooth camera. It doesn't perfectly follow the player. It has a little bit of a delay. That's literally all that it does, and then it's just being created at the create event. Okay, now in our step event, we are calling that depth. So remember, SCR depth 3D, this just determines in what order this is drawn, either in front or behind. Really simple there. And then for our draw, we're doing draw sprite 3D. Now we're not doing stacked because this is a 2D image. We're just simply having this drawn, rotated along whatever our global.z is in that very instance. Keep in mind, if you don't already know this, the draw event actually updates every single step. It's basically like the step event, but specifically for drawing. Now, key left and key right, this is just the rudimentary camera controls. So we're doing either, when you're holding left, it's rotating to the left by 1 degree at a time. And then the same with the right. And then that's why here in, I believe it was this one, we have these locked is because, so right here we have this locked because in the player, we're just simply using numbers. So 360 plus 1, plus 1, plus 1, plus 1, that's going to be above 360. And so we're just locking it in that script. Now, this is just very simple WASD movement, but there's a little bit of a trick to it. So we're using length dir X and length dir Y. And so we're basically, our movement is working in tangent with the global.z. And so, essentially we're just subtracting different amounts of degrees. So whenever we're moving upwards, for example, our player is moving along the X and Y axis in direct correlation with the global.z. Okay, so we have all of those. Now, if you'll notice, some of these have this little flip here, and some don't. A and D are the only ones that have flip. All that this is doing is this is flipping our character to the left, and that's why we went in here. Let's see which one. We went in here and we did image X scale and image Y scale instead of 1, because if we had these set at 1, which is the default, we would not be able to actually flip our character, depending on to the left or the right where they're facing. Now you could change this to where you actually have 4 or 8 different directions to make it look more 3D. I just did a basic left and right just so you kind of get the example of what that was, and then that would be, you could either do it based on where you're moving or where your mouse is positioned. There's all different kinds of ways that you can do that. And so this is just an emergency game end since we're going to full screen. That's not really super important. And then we're just inheriting from our parent here. So we've pretty much got the bulk of this code out of the way. The rest of this is really easy. So yeah, this is just calling the 3D script, the same one that we use in the player to determine the depth at which it's drawn. And then we're also doing the same one the player uses. It just rotates it from its base along the z-axis. We've inherited from the collision, and if you'll notice, our hitbox is at our base and not taking up the whole sprite like in a side-scrolling 2D game. So now this one operates differently than the 2D obstacle because there's 2 different ways to do it. This is where we're still implementing that 3D depth, but we are now calling for the sprite to be stacked rather than drawn along the z-axis. So it's still stacking along the z-axis, but if you'll remember, check out Heartbeat's video. He does a really good job at explaining that. And I probably did a terrible job earlier. And so for this, you would actually... So this technically is going to be the base, and then it would be drawn extended upwards or extended in whatever direction the z-axis or the view angle is facing. So yeah, it can collide with other physics collidable objects. And I already went into the camera. It's just a simple smooth camera script. Nothing fancy about that. And now let's just check out the room properties really quick. And this is pretty much the last thing. So yeah, we just have a few things in the room right here. And then if we go to, yeah, we just have this set as the repeating background, just a little simple grid. And then, okay, let's check out the viewport. So the viewport, yeah, nothing crazy here. We're simply following the camera object. And then for the room physics, since this is a top-down game, make sure to enable physics in all of your rooms, and then make sure to not have any gravity set like in a normal 2D game. Otherwise, everything's going to fall negatively on the y-axis for no reason. And remember, they're already on the ground, and we're not using any gravity. So yeah, that's pretty much it. Here's one final look at some of that gameplay. And you can really expand this a lot. You can do a lot with this. This is just simply a way to get started, and then you can kind of let your imagination go from there. But yeah, there's a look at the project file, more in-depth explanation. I absolutely love getting comments like this one from Egglocks. It feels really good knowing that I could help somebody. And even if I can just help one person, my job here is done. The reason that I started this YouTube channel was to help you, whether you're a beginner, an expert, and you know way more than me. I simply feel that I owe it to the GameMaker community to pass on the knowledge that I've learned over the years. And I still have a lot to learn myself. I still have a far way to go. But in the meantime, I'm always going to continue passing on my knowledge, just trying to help as many people as I possibly can. So if you liked this content and you'd like to see more, please consider liking or subscribing. Every subscription and like helps this channel grow, and I can reach more people and hopefully help just one extra person really make the games that they want to make. If you did find this tutorial helpful, please let me know in the comments below. I'd love to see what you guys are making, and if you are struggling over anything, or if you have any tutorial suggestions, or even if you'd like to just chat with me, I'm always willing to engage with you in the comments. But that's going to be it for this video. I will see you guys in the next one.